Alright guys, so I want to talk to you a little bit about exponential applications, okay? The first exponential application that I want to discuss is essentially percent increases and percent decreases. Okay, so this really kind of comes from the simple interest formula, where we can say some kind of an amount is equal to our initial value, and then what we're going to do is we're going to either increase or decrease by some rate. So that's going to be 1 plus or minus percent to the t power. Okay, so this is our starting value or population or starting amount that we're investing. R is going to be like a percent increase. Oftentimes this is going to be like annual per year or so on. This is going to be our final amount after some given period of time. And T represents time. Okay? And this is just our basic simple interest kind of formula. For example, let's say I have a population of 100,000 and it increases at a rate of 3%, let's say every 5 years. Write a formula for the population. Where t is in years. So this is going to be the amount is equal to 100,000 times 1 plus 0.03. Now if t is every year, we're not adding 3% every single year, we're adding 3% every 5 years. So when t hits 5, that's when we're going to be doing this 1 plus 0.03 times 100 grand. So the easiest way to do this is to divide this by 5, make it t over 5. All right, so now when you hit 10 years, you're going to be adding on 3% twice. And when you hit 15, you're going to be adding on more than that. Now, I've also seen some questions ask that they want you to write the formula as something like a times b to the t. And it asks you, what is A and what is B equal? Well, obviously, A is still our starting value of 100,000. B, because they just want to have the exponent t up top here, and they don't want to have that, we can actually turn B into 1 plus 0.03 to the 1/5 power. All right? Evaluating that in your calculator would give you a base that you could use. All right? One other formula that you might see is like half-life or doubling. Okay, these are both exponential models where it looks a lot like the last one in that your amount after so long is equal to your starting amount. But like if we say that the population is going to be cut in half every 8 years, it would be 1/2 t over 8. So when t equals 8 years, you're taking half. When t equals 16 years, you're going to take half twice. and so on. And so that value in the denominator represents your halving time. Likewise, doubling time would be p sub 0 2 to the t over h, and that is where h is equal to the doubling time. All right, so I hope this helps you with some of the applications that we have here for exponentials. We'll be doing more and solving them for t, after we get back from break and we kind of look a little bit more at this. All right, thanks.